Hey, what's up, bro? Bro. What? Did you tell me that we're going to leave something to make a video?
Yes, here I am listening to music.
Look at this curious speaker. Okay, this is it. What is this? What is it? Gadgets from AliExpress. Yes,
A speaker.
speaker. This is not a Tesla coil. Something similar. No, it's not a Tesla coil. I'll take it now and make a video. Tell me about it in one of your videos. Okay. Okay.
Okay. This is not a Tesla coil. Well, let's see. If it does the same or similar thing as a Tesla coil, let's say that the end result is similar, but not the process to do it. A Tesla coil uses a resonance system with a capacitor and a coil to achieve a specific resonance frequency to raise it by means of two coils, that is, a transformer, sacrificing the current in favor of increasing the voltage, but not by hundreds, no, but by thousands and thousands of volts. What I have in my hands is not a Tesla coil, it is an electronic system that, through a circuit and components, generates an alternating current frequency that is elevated to thousands of volts, but with a very small amperage. That is why you cannot get electrocuted. Well, let's see. Only little tickles or shocks, sort of controlled. Come on, I don't like this very much. It all starts with a transformer, that is, a power supply that transforms the input current into direct current at 48V. 48V is already a respectable voltage, but it is welcome, since it will be easier to work with these high voltages and not have to make the circuit work so much from such low voltages. Even so, we can see that it has heat sinks inside. These little devices should be used for a few seconds or at most a few minutes if we do not want to burn them. We see that it has a complex circuit because in addition to generating high voltage through the electronic circuit, not like a Tesla coil, it also accepts the introduction of sound electrical frequencies, so in jack mode, you know? With the music jack or even via Bluetooth with this circuit that we see here, which is the Bluetooth connection. So we could more or less be listening to music through these downloads. Indeed, the power supply is 48 volts and would offer a maximum of 2 amps. With my source I am going to measure the current and voltage. I put 48 volts and we see that when it is running at minimum it consumes 100 amps. We are talking about a minimum power of less than 5 W. And at maximum it is around 1 amp. We would be talking about a power of 50 W. Be careful. I am not sure of its operating frequency, but my multimeter detects about 500 Hz of alternating current without making physical contact, only by the electromagnetic waves it generates. Besides, this frequency is not continuous. We see that it delivers about 4 discharges per second at minimum speed. The switch to the right is the option for synthetic discharges, that is, as is. The switch to the left takes as a reference the frequency of the music that we play, either via jack or Bluetooth. The potentiometer on the left regulates the power of the shots and the one on the right regulates the discharges per second. We cannot measure the voltage because to do so I would need a measuring device that can measure thousands of volts. Furthermore, the current is so small that the resistance of the multimeter already consumes part of that very small current and the measurement is not real. we can more or less measure the current. And we see that the current is very small, a few milliamps, so much so that we can interpose an LED diode and it will not burn. And we know that the discharge current is alternating because the LED diode lights up when placed in both directions. During the recording, I can smell the air, as if it were ionized by the variation of electrical charges in the environment, as a typical air ionizer usually does. The thing is that this one is very noisy and we can't use it for many minutes, yeah.
No hacemos contacto, ¿verdad? Con la alimentación. ¿Se nota algo? ¿Se nota algo? No, a mí no me toques.